In this video, we will discuss Application Program Interfaces, or APIs for short. Specifically, we will discuss what an API is, API libraries, and REST APIs, including request and response, and an example with PyCoin Gecko. An API lets two pieces of software talk to each other. For example, you have your program, you have some data, and you have other software components. You use the API to communicate with other software via inputs and outputs. Just like a function, you don't have to know how the API works, just its inputs and outputs. Pandas is actually a set of software components, much of which are not even written in Python. You have some data, you have a set of software components. We use the Pandas API to process the data by communicating with the other software components. Let us clean up the diagram. When you create a dictionary, then create a Pandas object with the data frame constructor, in API lingo, this is an instance. The data in the dictionary is passed along to the Pandas API. You then use the data frame to communicate with the API. When you call the method head, the data frame communicates with the API displaying the first few rows of the data frame. When you call the method mean, the API will calculate the mean and return the values. REST APIs are another popular type of API. They allow you to communicate through the internet, letting you take advantage of resources like storage, access more data, artificial intelligence algorithms, and much more. The RE stands for representational, the S for state, and T for transfer. In REST APIs, your program is called the client. The API communicates with a web service you call through the internet. There is a set of rules regarding communication, input or request, and output or response. Here are some common terms. You or your code can be thought of as a client. The web service is referred to as a resource. The client finds the service via an endpoint. We will review this more in the next section. The client sends requests to the resource, and the resource web service sends a response to the client. HTTP methods are a way of transmitting data over the internet. We tell the REST APIs what to do by sending a request. The request is usually communicated via an HTTP message. The HTTP message usually contains a JSON file. This contains instructions for what operation we would like the service to perform. This operation is transmitted to the web service via the internet, and the service performs the operation. In a similar manner, the web service returns a response via an HTTP message where the information is usually returned via a JSON file, and this information is transmitted back to the client. Cryptocurrency data is excellent to use in an API because it is constantly updated and is vital to cryptocurrency trading. We will use the PyCoin Gecko Python client, or wrapper, for the CoinGecko API, updated every minute by CoinGecko. We use the wrapper, or client, because it is easy to use so you can focus on the task of collecting data. We will also introduce Pandas time series functions for dealing with time series data. Using PyCoin Gecko to collect data is simple. All we need is to install and import the library, then create a client object, and finally use a function to request our data. In this function, we are getting data on Bitcoin in US dollars for the past 30 days. In this case, our response is a JSON file expressed as a Python dictionary of nested lists, including price, market cap, and total volumes, which contain the Unix timestamp and the price at the time. We are only interested in price, so that is what we will select using the key price. To make things simple, we can convert our nested list to a data frame. With the column's timestamp and price, it is difficult to understand the column timestamp. We will convert it to a more readable format using the Pandas function to_datetime. Using this to_datetime function, we create readable time data. The input is the timestamp column. Unit of time is set to milliseconds. We append the output to the new column date. Now we want to create a candlestick plot. To get the data for the daily candlesticks, we will group by the date to find the minimum, maximum, first, and last price of each day. Finally, we will use Plotly to create the candlestick chart and plot it. Now we can view the candlestick chart by opening the HTML file and clicking Trust HTML in the top left of the tab. It should look something like this.